So yesterday we looked at my new Home Lab 3.0 and we looked at the process I went through to install single node OKD. So I want to demonstrate actually deploying single node OpenShift. I couldn't do OKD because there's no ARM64 image that I can just run easily on my MacBook. So I'm going to do OpenShift, which does have an ARM64 image, and I'm going to walk through that process with y'all today. So we'll switch over to... So I want to walk through the installing it manually one, which is the documentation I have here on the right, because I generally don't really like magic. So I like to show how things are working. There's a few ways you can install single node OpenShift. You can do it with IPI. It does actually work, although it's not documented. So you would do it in a similar way to what we'll do here, where we'll set the masters to 1, and then you would just run the IPI install, and it'll create a bootstrap node. It'll deploy the master, then it'll shut down the bootstrap node to be left with a single node. But I want to walk through this officially supported manually doing it way. So the first thing we're going to do is we're going to export the OCP version 4.14, and we'll set arch equal to arch64 for ARM, and then we're going to run this curl command to download the client library of the client binaries, and we'll download the install binary. So I just skip these 2 steps for now. I'll extract them in a minute because I already have OC. I'm pretty confident I don't need to do that first bit. Okay, so we've downloaded the installer there, so we'll just extract that. So the URL in that command to download the OpenShift install, it doesn't actually have the architecture in the URL, so we might need to fix that in the documentation. And it downloads the Linux version, so I'll also need the Mac version. So what happened was, when I tried to execute it, you get this exec format error because it's trying to execute an x86 instruction set on an ARM CPU, which obviously doesn't work. So I've just gone to the mirrors page, which is this URL here, and I'm just going to download it myself here. So we might just need to update that documentation so that if you have that architecture, if you've exported that architecture variable, that we download the correct architecture OpenShift installer. But in the meantime, I'll just download that and then we will copy it over and we'll keep going with the documentation. So it looks like that download's finished now. So we'll just copy that from my downloads folder. So we'll copy that to here. Okay. Don't execute permissions. Oh, we don't want to execute the binary, the tar file, we want to execute the binary. So if you're on a Mac, you just need to allow that to execute. So you go to your settings, privacy and security. It says that it was blocked here, so you just click allow anyway. And now I should be able to execute it, which I can. So now we can move back on to the next step here, which is getting this ISO URL. So I don't use that command because I use the, that command should work fine. I mean, just using JQ is a little bit more elegant, I think, for doing this. So you can see there, I've used JQ to pull out the architecture. So I'd say they've just done this so that you don't need to install the JQ command on your system for it to work. Like grep should be there. That's probably why they've done that, to make it more accessible. But ultimately, I generally will just use this command, do curl-o, some parentheses there, and paste that command in, and that'll download that real CoreOS ISO for us that we can move forward in the next steps with our documentation. So we'll just wait for that to download, and then we will do the next steps, which are creating our install YAML file and editing that ISO. Okay, that's finished downloading now. So moving on to the next step, the documentation, that's curling it. So now we want to create our install-config.yaml. So I'm just going to copy the one from yesterday. So we'll take another look at this. So we're setting workers replicas to 0, control plane replicas to 1. We don't need to change anything else here. We're going to use the bootstrap in place installation disk of dev SDA. Now, as I explained in the video yesterday, you might actually want to get the proper ID if you have multiple disks in a system. In this case, there's only going to be one disk, so I'm just going to do dev SDA. And we'll just have to make sure in the VM that we're using the SATA adapter so that we do get dev SDA and not VDA or NVMe or whatever else. For pull secret, so this is where we need to actually put in a valid pull secret. So to get the pull secret, so down here in the documentation you can see copy the pull secret from the cost manager. So I'm going to do that on a different monitor. So the pull secret I put here was just from the video yesterday. It's not actually a valid one. So I'm going to replace that with a valid pull secret on another screen before we execute. And then I've just put in my SSH key there. So I'll just update this pull secret really quick. All right, so pull secret's updated. So what's the next thing we need to do? We need to make a directory called OCP. And we need to copy in our install config to OCP. Then we are going to run this command. All right. Now that has worked. So we're just going to set up a Podman machine locally so we can keep running these commands on my MacBook without having to go to a Linux system. So just setting up a Podman machine here. And we're using the -- root flag, so we'll do Podman machine start. Okay, so we have a Podman machine running here now. Okay, so we've created a Podman machine on my MacBook now. So we do Podman system connection list. So we can see here we've got a few options. Okay, so this server one, that was my R710 that died in the storm, so I can't use that, and this work VM is gone, so I'm not using a work VM anymore. I'm actually using just a pod, which I'll make another video on, but I just use this pod, so I'm not going to use that either. I'm going to use this Podman machine here. So we're going to do Podman system connection default, and we'll set that one as the default. So now if we check again system connection list, we can see that we've changed this one to true. So what we're going to do is just do a Podman pull Fedora latest to make sure that works. And we can see that it is working, it's trying to pull it. Okay, so the next thing we need to do is go back to our documentation and we need to alias this CoreOS installer command. And now we're going to run it, but I haven't named my ISO that, have I? So we need this part of the command. And then the last part of the command will, oh, no. So copying the command, we will paste the command, but we need to change the ISO name. RHCOS, that's it. All right, so let's see if that works with Podman machine on a Mac. Never tried it before, but we'll find out. This is the kind of thing that I was doing on my work VM previously. So I can get Podman to work inside a container. I might be able to do it in my work pod. And I do have a ThinkPad for work. It's just easier to record these videos when I can use the cameras on my iPhone instead of my webcam. So it looks like that has worked. It's written the manifest. So now this ISO is what we can boot our VM from. So let's go and create a new VM. So we're just going to create a new VM. So go here, I'll grab that ISO. So here it is here, drop it in there. Continue, so it's going to be a rel image. And we're going to customize some of this stuff. So we'll call it OCP Snow. Save that. Now customizing our settings. We will give it 8 GB of RAM and 4 CPU cores. And for the disk, we need to change that because it's currently using a VMDK, which it's currently using, NVMe. So we need to change the bus type on the disk. It's currently using NVMe. We want it to use SATA so that we get that dev SDA. We'll apply that. And I think that's all we need. So now we can start up our VM. So now it's going to boot into rel CoreOS, and it has that ignition file already embedded in the image. So it will boot from the image first, and it's going to run a bunch of stuff within the live image, and write that to dev SDA, then it will reboot, and that's when our OpenShift deployment will actually begin. So we can see here we've been given an IP address 172.16.66.131, so we'll SSH to that because we gave it our SSH key, core at 172.16.66.131, and we can see we're able to log in there. So this isn't currently running on the hard drive, this is running from the live disk. So we do fdisk -l. We can see that we have SDA. Oh, we only gave it 20 gig, I should have expanded the size of that. I don't know if it'll fit, we'll see. So we look in mount and we grep for SDA. We can see SDA is not actually mounted anywhere. So we've got this disk, but it's not mounted. And if we follow along with the journal, it's trying to reach this and can't, DNS isn't working. So the same issue I had yesterday with Fedora CoreOS. Resolve CTL, DNS. Looks like rel isn't using resolve D yet. So we'll go to resolve.conf and we'll just change this DNS server. Not sure why that doesn't work, to be honest. But we'll go with just my router as the DNS server, and we should be able to ping quay.io now. So we can't ping it, but we can resolve the IP. So we'll follow along with our journal again. So just be careful with these errors like this can't talk to a v1 container registry. We're actually getting that error because it can't resolve the IP address of quay.io. So it's a little bit misleading if this is the first error you looked at. You're like, what does it mean? Can't talk to a v1 container registry. Just make sure you double check. I've had this happen on my laptop as well, and it's always been a DNS issue resolving the registry. So what we want to see here is we want to see it actually downloading that release image of rel CoreOS so that it can write it to the disk. So that's basically what we're waiting for at this point in time. Alright, so we're having the same issue that we had with OKD, where it's trying to download a x86 image. So let's do a little bit of debugging here and see if we can figure this out. So we'll go to where the release image is coming from. The release image comes from here. So here's an ARM image, right? Let's try with this one. Okay, so let's change our release image in this file. I'm going to set release image equal to this one. So if this works, then what we need to do is figure out what we did wrong in the installation process. And this is actually looking promising. Core. Okay, so what did this have to say? All right, so okay, that has managed to download the image. So all right, it's probably not worth pursuing at the moment, but let's grab that release image because we know that that was a problem. So we'll go back in here. This is the release image we want. So let's go back to our installer. We'll just shut this down. So the problem has to be with the ignition file, right? So there has to be something we're doing wrong with the ignition file. So if we do export OpenShift install release image override, and we paste that image in, and then we do, so let's just export that for now. We'll rf the OCP directory. We'll make the OCP directory and we'll copy in our install-config file. So now, when we make the ignition file, let's do it with this exported. So we've exported an override to our release image and we're overriding it to the ARM image. So now we want to make that IGN file again. So we'll do OpenShift install directory in the ignition file. Okay, so you can see here that it has picked up the fact that I'm trying to use an override there now. Okay, so the next thing we want to do is we want to re-embed that into the image. So we'll run that again. And we're going to start a new VM on that again. So we'll drag over our ISO again, continue, it's going to be rel. Customize it, we'll give it a bit more storage space this time as well. So this will be OCP Snow. And we want 4 CPU cores. The disk, so we'll go change the bus back to SATA and we'll make it 60 gig. Apply. I'll just delete this one too. Okay, now we'll start up our new VM. So let's see if it downloads from that ARM-based release image now instead of trying to do the x86 one. Okay, so it has downloaded the release image and it's starting to bootstrap now, so it looks like that did work. Alright, so we want to find a 4.14 release image. So we have 4.14. Okay. So we'll set this release image to a 4.14 one because the installer is also 4.14 now. Oh, we don't need a WQ with that. So we'll rmrf the OCP directory again, and we will make OCP. So we're just adding in our architecture ARM64 into the install YAML file, and we will copy that back over to the OCP directory. And let's try building that ignition file again. So it's picked up our image override to the ARM one. Alright, so we'll embed that into the ISO again. And let's again get that VM booting. Alright, so our node has written to disk there now, so we need to make sure it boots from that disk though. It just rebooted back into the attached ISO. So, start up disk. Can I just disconnect it? Let's see if that works. Okay, that's better. Now we're booting from the actual hard drive now instead of the ISO. So this should continue now. Obviously it's installed to the disk. We're actually booting into Linux now, which is great. Okay, so we've come up with the same IP address and a different key. Okay, so we can see we're no longer in just a bootstrap node. This is actually running OpenShift here now, which is great. So a few things we're going to need to fix. We're going to need to fix the DNS server again. We can't have that. Just give it 1.1.1.1. And I actually already have a DNS entry for the API int address. So we're going to just set a static one to this address. And that should allow everything to start up. So let's talk about how I figured out how to use that environment variable. This isn't something that's just insider knowledge that I knew. What I did was I git cloned the installer project and I just grabbed for release image because I know that the problem is the release image variable that's set in that download release image script, and it's pulling an x86 image, and what I need is an ARM image. So what I did was I just come here and I did a search and I found this file here, this alternate release image sources.md. So I had a look in that markdown file, and I basically just read this file and then I stopped. So the installer controls both the release image content and the source using the embedded release image location, or the OpenShift install release image override environment variable. Basically at that point I just decided, all right, well, I'll try overriding the release image. I didn't bother reading any further or looking at how that's used in any of the other scripts. That seemed like a good enough lead for me to go off. So I didn't just make that up. I cloned the installer repo to see how a release image was set, and in doing that I found that there's an override option. So then I just used the existing release image we had and the registry it's being pulled from Quay to go check to see if there was an ARM build, which I know there wasn't for OKD, but I checked with OpenShift because I know that OpenShift does support ARM. So I found that image and then decided to specify that as my override in this case. So there's probably still something going on with the installer. The installer should have the embedded correct architecture because I did download the ARM one, and that's probably something I still need to look into. But this is a good example of, you run into problems and we don't just need to stop because we've hit a problem. We can explore how it actually works. And this is a good example of that. We cloned it, we had a look in the repo, we found an alternate option, we tried that out. We haven't explored why it works or what else it does when we specify the override. We just found that it was an option and it was worth trying out. So back on my single node, it has downloaded the new OS tree image and it's rebooted from that. And now it's going through the process of actually starting OpenShift. So we're going to let this run for a little bit longer, and we will hopefully start to see Kubelet start up, Creo start up. It'll pull containers, which we can see it's already done over here. And once they're up and running, we should be able to then connect to it. We do have a release image Podman container, so that's just downloading the release image, which should be enough to get everything we need on the system and then start the cluster version operator, and that will then dictate how everything else is orchestrated and deployed from there. So we're just waiting at the moment. We'll follow along with those journal logs and we'll come back once it does something a bit more exciting. All right, so checking back in, let's see how things are going. We've got some containers starting to start up here now. So let's check to see if our API is listening. If I can type. Yep, there it is, 6443. So API is listening. So if we go back here, cool, we can see that we are starting to get some API responses. We're starting to get some containers running. So these containers here are just waiting for that node to be ready. So the node will need to come into a ready state, and then we will have a node for those containers to be assigned to, scheduled on. So I feel like at this point, the video is probably long enough. We can see that that's starting to work now. So the key things there for me, I know it turned into a way longer video than what I initially thought it would, but the key things there were that it didn't work when we first started out, and there were things we needed to do. And the important thing is we don't just give up when the first thing that doesn't work is at some point someone has put their hands on a keyboard and written logic that defines how this works. Someone has written how that release image ends up in that file. So just knowing that, we know that we can go and find certain strings, like the release image string was a really obvious one to start looking for. There's always an answer. We can always find a solution. It's just about thinking about how did that logic create that file to begin with, and where do I need to look to understand that logic, and then start to influence how that logic reacts to my installer behavior. So this is how you would, at the moment, deploy and get something running up on ARM. It should work from the installer. I haven't tried the Linux ARM-based installer. I can try that. I do have a Fedora VM on my MacBook, which is obviously ARM. So maybe I'll give that a go and just see if that changes the behavior a little bit. Maybe it works, and maybe it's just a bug with the way the macOS one was compiled. Worst case scenario, you can always compile yourself from the installer repo, build your own OpenShift install, which will have the correct release payload. But yeah, the big takeaway is just finding solutions to these problems, even if the documentation in this case is written, it all works. If you're deploying an x86, that's how I deployed my ThinkCenter device. But when it comes to running on an ARM node, it didn't work, and we had to figure out how to make it work. So I'll follow up on that from the documentation side, see if there's anything that I was missing, something that I should have done differently, and if there is, I'll let you guys know with an updated video. But for now, I don't think there's much else to show at this point. We've all seen what happens with OpenShift from now Just take another real quick look to see where it got up to. So the node's still not ready at the moment. It's probably waiting for the CNI or something to start. So the best place to follow along if you're in this same situation is just, just with the journal logs at this point, just follow along with that. So you can see the network's not ready. So we're waiting for the CNI to start. And once that starts, the node will go into a ready state. And then you can check along with any of the containers that have been started to this point with cryctlps. So you can see that it's actually starting the network operator now. So that will probably go and deploy OVN Kubernetes and start the CNI on the node. So I'll leave it there. It's a follow-up to yesterday's video. I wanted to do something that demonstrated an actual deployment, and I'm glad we were able to capture some of the troubleshooting that was involved in doing that. So if you have any questions, feel free to drop in the comments. Happy to answer. I'll probably post this on Reddit, and I will I'll answer questions there as well. Thanks again. See you in the next one.